Right, we're looking at the 2009 Queensland Senior External Exam in Physics. This is Paper 1, Part A, Section 1, Multiple Choice, and it's Question 8. First thing we do is we read the question. The double slit arrangement shown below was used to estimate the wavelength of monochromatic light. We have two slits, S1 and S2. The light passes through the slits, diffracts, and the two diffraction patterns interfere, and on the screen we'll get dark and light bands. Now the distances PS2 and PS1 is known. A maximum occurs at P. To find the wavelength of the light, which other measurement is required? Is it L, the distance that the screen is, X, the separation of the slits, the distance S1, S2, which is the separation of the slits, or the number of maxima from O to P. Right, we've read the question once. Let's come back now and identify the important pieces of information. Right, it's a double slit experiment shown below, used to estimate the wavelength of monochromatic light. The distance PS2 and PS1 is known, so we know this distance and we know that distance there. A maximum occurs at P, so we know that it's a whole number of wavelengths. So if it's a maximum at P here, so here we know that that's a maximum. So therefore the path difference PS1, let's go with the larger one, PS2 minus PS1, it's got to equal n lambda, where n's an integer, 1, 2, 3, 4, etc. like so. Or actually 0 for the central maxima. The path difference, if it's the first maxima, it'll be one wavelength. If it's the second maxima, it'll be two wavelengths. If it's the third maxima, it'll be three wavelengths, etc., etc. Okay, so we're identifying the important piece of information. The diagram's already drawn for us, so let's have a look and see how we're going to decide. This particular formula here is the key, that to find the wavelength of the light, which other measurement is required. Because it's a maxima, as I was saying before, the central maxima is 0. If it's the first maxima, it's one wavelength, second maxima, it's two wavelengths. So we just need to know the number of maxima from O to P, because PS2 minus PS1 equals n lambda. That's the for constructive interference. So for the central maxima, n equals 0, so the path difference equals 0, so PS2 equals PS1. For the first maxima, n's equal to 1, so the path difference is equal to lambda. PS2 minus PS1 equals 1 wavelength, and so on and so forth. When n equals 2, path difference is 2 wavelengths. PS2 minus PS1 equals 2 lambda. Now, given that it's just a multiple choice question, the answer to that should make sense.